Okay, well, good afternoon, everyone. Welcome to the first day of reInvent. I'm Nick Colt. I'm General Manager of Amazon Elastic Container Service, and I'm here today to talk about supercharging your business with Amazon ECS. I have some folks going to be joining me on stage, Jeremiah Dooley, and then Grant Milstead from United Airlines. Got a great customer story to tell about their journey with ECS and Fargate. So I want to talk a little bit about the agenda here. What are we going to be covering today? So the first part of the presentation is going to be a bit philosophical. I'm going to be talking about what is serverless, why use serverless, how should you think about serverless. And then we'll get into some of the details of ECS and Fargate and how it fits in with the serverless landscape on AWS. And then we have a really fun demo that shows a real live example of speeding up applications using Fargate and some of the technology and innovations that we've launched recently. And then Grant has a fantastic story of the journey they went through in United with the United mobile app and United.com website. And then we'll have a Q&A with Grant, and then we'll wrap things up. So first I want to talk about why serverless. And if there's one thing that I want you to walk away from this talk with, it's actually the message on this slide. The whole reason that we exist in serverless, or the biggest benefit that we see and the reason why we do what we do, is to help you as a customer move faster. You know, in today's world, things are changing all the time. The economy's changing, technology landscape is changing. You'll see in Grant's presentation, the weather is changing, the global travel environment is changing, and the faster that you can respond to those changes and deliver solutions to your customers, the more successful you're going to be as a business. And so what we're trying to do here with serverless is help you respond to those changes, get to market faster, because the faster you can do that, the faster you can meet your customers' needs, and then you'll be differentiated in the market. And so that's the message that I want you to walk away from this presentation with, is faster time to market with serverless. So now that we know why does serverless matter, let's talk about what actually is serverless. Like, how should you think about what serverless is? And that's a term that's been out there for a while. It's used in lots of different contexts. Different people mean different things when they use the word serverless. And so I want to kind of talk about my opinion and my view of what serverless is and how we view it in the ECS and Fargate world about what is serverless. And it's really an operational model and a philosophy, almost a way of life of how you do business with cloud computing. And so one of the main things that we emphasize with that serverless operational model is we're taking away the things that you don't have to focus on so that you can focus on the things that matter the most for your business. We're taking away that undifferentiated heavy lifting. In the case of serverless, we're taking away managing servers and operating systems and clusters. One way that you can view it is this sort of stack view that we have here, where what we want you to focus on in the world of serverless is things like APIs and business logic. You own that, we own everything else. You focus on that, we take care of everything else. That's one view of how you can think about serverless. So AWS pioneered serverless with the launch of Lambda back in 2015. Now, Lambda is kind of the original serverless service, and a lot of people, when they use the word serverless, that's what they're talking about. They're talking about Lambda, which is a serverless function. And serverless functions kind of invented a new way of doing computing. You know, instead of taking all of your software and packaging it all up and putting it onto a machine and running it, you just said, well, my code is packaged up as a function, and I'm going to hand that code over to AWS, and it just runs whenever it needs to. Amazon runs my code for me. And that was a completely new way to run software, and invented this whole new category that later became known as serverless. But since that time, we've launched a bunch of other things. We've had over 31 major new features and capabilities and services launched since then. And this includes things like Fargate, which I'll talk more about what Fargate is later. But Fargate, which introduced the idea of serverless to the world of containers. And it's not just the compute, it's all of the things that surround that compute, like storage. The fact that now with Fargate and Lambda, you can have serverless compute, and then you can have storage with Amazon Elastic File System, EFS, which allows you to have an elastic, expandable file system that appears where it's needed. It's like serverless file system. And all of the observability integration so that you have telemetry and logs all managed for you and getting sent to the right destinations on your behalf. And so you're going to see us continue to make these kind of investments that improve the speed of deployment, that improve the compute capabilities, that improve security. Again, all coming back to that original message that I want you to walk away from this presentation with, which is that it's helping you move faster. So one of the ways that people think about serverless applications is in the context of what we call modern applications. So a modern application is, it's really a philosophy or an architecture where you take an application and you break it up into small components that are loosely coupled. And ideally, the coupling that exists between those small components is through asynchronous messaging or asynchronous buses like EventBridge. And the reason that you do that is, there's lots of reasons actually. One of them is really around just the way the technology works. You can create very, very scalable and resilient applications when you use a modern application architecture. But it's also about the people. Because when you have, your application is decomposed into small components, you can have different teams that own each of those components. And because they're loosely coupled, those teams can move really fast. Two different teams that own two different components that are loosely coupled, they're not blocked on that other team to go ship updates and to go ship code. So they can get in a really tight innovation loop, and they can be delivering faster because they're loosely coupled, because they own a small, well-defined set of code. And so those are some of the sort of process or people organizational benefits of modern application architectures. And what you see if you build modern apps is that serverless is ideal for modern apps. If you're going to build a modern application, you're going to use Lambda and Fargate for the compute, most likely. You're going to use things like API Gateway to couple those together, or EventBridge to couple those together. You're going to use DynamoDB and DocumentDB for databases. You're going to use EFS for storage or S3 for storage. And so we got an example here of a real application that's implemented using modern application architecture. There's lots of different variations of this, lots of different ways you can piece these things together. But I just wanted to kind of talk a little bit about this term modern application and what it means and how it relates to serverless, and that there's a lot of overlap there in terms of that philosophy of what you're trying to achieve and the time to market benefits that you get. But I do want to be clear, serverless and modern apps are not entirely equal to each other. You can do serverless without modern apps. I'll talk about that later. You can also do modern apps without serverless. You can use services like EC2 in a modern application architecture. So I want to lay out the landscape of serverless and serverless compute in particular and how we think about it. And I included EC2 here because EC2 actually does fit in this landscape. Now, it was the original cloud compute service. If you think about what happened when we launched EC2, you went from a world where people were buying physical servers and putting them in racks. I've done that myself. To a world where you just go to a website and say that you need a certain CPU and memory and processor, and you get it, and you pay by the hour. That was a huge leap forward on the amount of work that you no longer had to think about, you no longer had to do. And the agility, the lead time, instead of saying, well, you need to do server, wait 3 months, to, well, you have it a couple minutes from now, was just a complete change in how people did business. And I see serverless as another iteration and evolution of that, right? To go from on-prem data centers to VMs in the cloud well, now we're going from VMs in the cloud to your code is running and you're not even thinking about VMs, right? It's an evolution of that journey. And you can kind of look at this chart and see like how much you manage and how opinionated the solution is are coupled together in these solutions. The farther up and to the right you go, the more managed and the more opinionated it is. It doesn't necessarily mean that up and to the right is always better. That's not what we're trying to say. In many cases, it is better, especially if you're building a modern application. But there's a lot of customers out there. There's a lot of workloads out there. And we like to have, as we say, the best tool for the job. And in a lot of cases, EC2 is the best tool for the job. So the main point of this was not so much to talk about better or worse, but just to talk about what is the landscape and how do we view all the different types of compute that are available. So now I want to zoom in a bit and talk specifically about ECS. So what is ECS, Elastic Container Service? What does that mean? Well, we call it a managed container orchestrator. And so I want to kind of break down the words there. Managed means it's managed by AWS, obviously. In particular, it's a set of APIs. ECS is a set of APIs that developers and operators can use to do things like create a cluster or create a service or start up a task, which is a collection of containers. And those APIs are 100% managed by AWS. They are 100% versionless. You never have to think about what version you're running. You never have to upgrade them. We manage the availability for you. We launch those in regions around the world for you. And then the container orchestrator piece is, okay, the APIs are great. You need that to create things like clusters. Your application is running in code that's running in containers. So ECS's job is to manage the life cycle of those containers on your behalf. And so when you create an application using ECS, you have a set of container images that compose that application. ECS is going to manage the life cycle of the containers that run. It's going to make sure they start up and make sure they shut down, and it's going to orchestrate the life cycle of things like load balancers and EFS attachments and other things that are necessary for that application to run. So that's what we mean when we say ECS is a managed container orchestrator. So people love Fargate. I'm going to share some numbers in a little bit here. But the three main reasons why people choose this combination of ECS and Fargate together, one of them is what I already talked about, is this sort of serverless way of life. The fact that you don't have to think about a bunch of things. But there are some other very specific benefits I wanted to talk about as well. One of them is security. So the way that Fargate works, every time you run a task, which is a collection of containers, they get dedicated compute infrastructure. And what that means is that from a security standpoint, that task is completely isolated from all other tasks that are running, whether they're from the same application or from a different application. And so you get this built-in security isolation with Fargate. The other thing that's people really like from a security standpoint is when it comes to compliance. If you look at things like HIPAA and FIPS certifications, and there's a whole long list of various compliance things in different industries that people have to deal with, we deal with those on your behalf. We go through the process of getting Fargate certified under a whole bunch of different compliance regimes. And so you as a customer, you don't have to do that, which is different than the world of physical servers or VMs, where because you own the operating system, now you have to put that operating system up for audit if you're going to get audited by a government agency. So, and this is actually a really interesting flip that has happened with Fargate, where when we first launched it, there was more resistance among highly regulated industries because they thought, well, I got to have access to that server. I can't not have access to that server. How do I know it's secure? And now, those same customers say, oh, I don't want access to that server. I love the fact that I don't have access to it. It actually makes my life easier because now it's no longer within the boundary of things that I have to consider for things like compliance audits. And so there's been this really big shift, actually, where initially there was resistance, and now there's actually not just acceptance, but preference for that operational model for security purposes. Savings is the last piece. So we talked about some aspects of savings, like just the operational overhead, that you don't have to have teams of people managing infrastructure. But there's savings on actual compute cost as well. Because with Fargate, you pay for the containers that you're running, and you don't pay when they're not running. So you never think about cluster utilization on Fargate. You never have to think about how well packed are my containers onto my instances, because there's no such thing. You're paying for the containers, and if you're not running any containers, you're not paying anything. And so customers often don't realize this, but you can actually realize a pretty substantial cost benefit because of that. You focus on your application and its needs, and the infrastructure will appear as needed to support it, and you pay for the containers that are running and not for the infrastructure directly. And so those are kind of the three big benefit areas, the reasons why people choose ECS with Fargate is that serverless operational model, the security, and the savings that you can achieve. And so it's pretty popular. In fact, if you look at customers coming onto AWS and using a container service for the first time, about 2/3 of those customers are choosing ECS to run their containers. And of the customers who choose ECS, more than 70% are running their workloads on Fargate. And so Fargate has become, by a large majority choice for customers running on ECS. And it's for the reasons that we talked about. And it's now achieved absolutely massive scale. It's billions of tasks that are launched every week on ECS. Sometimes people ask me, well, this all sounds great, but how do I know that serverless is for me? Is it really for me? And the answer is yes, it's for you. If you look at all the different industries and customer types and sizes that have adopted serverless containers on AWS, it's almost every imaginable industry, almost every imaginable customer size, governments, nonprofits, educational institutions, financial services, travel, aerospace, you name it, there's somebody building an application in that industry running on ECS and Fargate. Not only that, but Amazon itself runs a lot of things on ECS and Fargate. So you have things like Amazon.com, the retail site. There are big chunks of that run on ECS. A number of AWS services internally are implemented on top of ECS. Amazon Prime Video runs a bunch of things on ECS. Fire TV runs a bunch of things on ECS. Now, I'm not just saying this because I'm proud of that fact, although I'm GM of the service, so I am proud to see that we're achieving that, but that's not really the point. The point is you as the customer benefit from all of the experience that we have in serving customers at this scale. Unless you think you're going to be bigger and have higher performance requirements than Prime Video or Amazon.com retail, you're not going to outgrow ECS. You're not going to outscale ECS. And so you as a customer, by virtue of the fact that all of these Amazon and AWS teams use ECS, you benefit from that. You benefit, we often say there's no compression algorithm for experience. Well, we got a lot of experience running a ton of different types of applications at mind-boggling scale. So I want to spend a little bit of time now talking about the other end of the spectrum. We've talked about those really giant applications. We've talked about those modern applications, those exciting new serverless modern architectures. But the reality is not everything is a modern app. Not everything was built by a team of engineers trained in the latest practices and building modern application architectures using all the latest AWS services. There's a lot of business critical applications out there that were written by somebody who maybe doesn't even work there anymore, and you don't have the source code anymore. And you still got to keep those things running, right? And maybe eventually you'd like to modernize them. You'd like to refactor them and turn them into a modern app, but you don't get to just shut it down and wait 6 months or a year while you do that. And so the beauty of ECS with Fargate and the fact that the container programming model is just software, right? That's what the container programming model is. If it's software that runs on a Linux or Windows machine, it can run on Fargate. So you can take your old application, you don't have to modernize it first. Get it running serverless first. Take away that heavy lifting of managing the server and of scaling the clusters and just run the thing that you have, right? Once you've got it running in a serverless environment like Fargate, then if you want to, you can go through that process of modernizing it. But you've already achieved the serverless benefits, a big chunk of serverless benefits, just by taking what you have and getting it into the cloud. And I don't mean offense to anyone from Nebraska here. I have family in Nebraska. It's not about that. It's really just about the fact that, software comes in a lot of different shapes and sizes, and not all of it is shiny new modern applications. And what we aim to do is serve all of those use cases. So I just want to remind you again of what the point of all of this was so far, which is faster time to market, get to market faster, move faster, respond to customer needs faster. And so we've got a number of innovations aimed at helping you do exactly that. I want to talk about a few of those here. And so we're going to actually cover this one in a little bit more detail in this session here, but if you want to see more on this, what we call SOCI or Seekable OCI, we've got a session on that and a workshop on that later this week, tomorrow. And then we just launched this really interesting capability called Guard Duty for ECS that launched yesterday, and I'm going to spend some time talking about that as well. So these are just some examples. There's a bunch more things that we've launched in the last 6 months that I didn't have space for. But these are some of the examples of the investments that we're making. So let me talk a little bit about what Guard Duty is. So the security space has evolved really in really interesting ways, and one of the most interesting developments in recent times, in my opinion, is the use of what's called eBPF for runtime monitoring. eBPF is a Linux kernel technology that enables a lot of different use cases, but one of them is to be able to monitor in real time what's happening with code that's running in a Linux machine, and like what systems calls is making, what resources that it's accessing. So what Guard Duty does is it enables what are called eBPF probes on EC2 and Fargate with Amazon ECS, and then it aggregates all of that threat detection data in real time into a single place in the Guard Duty service. And enabling this is as simple as clicking a button. Like you just turn it on in your account, and now you've got Guard Duty enabled across your entire account. Like all your Fargate clusters will be automatically turning on the security monitoring capability. So it's a really good example of the serverless operational model. Instead of us saying, oh, you like our security solution? Well, here's a 17-page process to go install it. It's no, click a button and it's installed. There's nothing to install. It's just there and it works. Another example is called Seekable OCI. So this is another example of a recent innovation that enables customers to move faster. And so what Seekable OCI is a technology that we've built. It's actually open source, but we built it into Fargate, and it speeds up container image downloads. Well, not exactly speeds up, but it reorders them. So that when you start up a container, normally when you start up a container, the first thing that has to happen is the container image gets downloaded, and the entire container image has to get downloaded. And in today's world, when more and more people are running things like machine learning, where you might have a 3 gigabyte image, or you're running Windows, which often those are large as well, you have to download that entire image before that container can do anything. What SOCI does is says, I'm going to figure out which parts of that container image you actually need based on the requests that are made to the file system, and then I will download on demand, and the container can actually start up and start doing work before the image is downloaded. And this can have dramatic improvements in the time it takes to launch a container. And that matters. That is speed. That is speed of deployment. Your developers say, we got a new idea, we want to test it out. The speed of the deployment, in part, is driven by how fast the containers can launch. And it might not seem like a big deal to go from 10 minutes to 1 minute on a deployment. It's actually a big deal for a developer, right? They can get in that inner loop. Or if you're talking about scaling for big events, like the speed with which you can launch a container matters. So this is an example of the kind of innovation that we're continually investing in behind the scenes. It's built into Fargate. You don't have to do anything to install this. It's already there. And you're going to see more of these kind of innovations over time. I love doing this kind of thing for customers. My favorite kind of innovation is everything got faster and you didn't have to do anything. So we're actually going to do a little demo of SOCI here. We're going to show some actual container launches and see how fast they are before and after. And so for that, I'm going to hand it over to Jeremiah, who's going to run through the demo for us.
Thank you, Nick. Hey, everybody. My name is Jeremiah Dooley. I run the developer advocacy team for ECS. And part of our job is to talk to customers and have customers tell us the things that are broken, have them tell us the things they want to do better, have them tell us the features that they'd like to have. And we generally break these into like easy problems and hard problems. Sometimes people will come to me and say, I would like this to be faster, more reliable, and cheaper. And sometimes people come to me and say, I would like you to increase the speed of light because this thing needs to get done faster. The second one is, ironically, the easy one. And so we're going to look at that today. What we're going to talk about here is the feature that Nick pointed out, the feature that Nick just talked about, the Seekable OCI. And what we're trying to do here is make time just a little bit squishy, particularly when it comes to images that we have to pull down from the Amazon ECR, the Elastic Container Repository, and be able to pull things in, start them up. When we do this, we've got a couple different things that we want to focus on here. And really what we're trying to do is make this as easy to implement as possible while still giving you as much functionality out of it as we can. So the idea here was that this started, and Nick pointed a little bit of this out, this started as an open source project. We took the project and we wanted to be able to implement it as cleanly and as silently as we could. We didn't want to be able to change, we didn't want you to have to change any of the constructs around what you're doing from the ECS standpoint. We didn't want to change how clusters were built. We didn't want to change how how the task definitions were built. We wanted to make sure that things were as clean as we could possibly get them from an implementation standpoint. And so what we're going to do is we're going to walk through here. And the first thing that we're going to look at here is a standard ECS cluster. And this cluster there's nothing in it. You can see down at the bottom there are no task definitions. And what we're going to do is we're going to go through and we're going to create two different task definitions. The first one is going to be a PyTorch training task definition. And then the second one is the PyTorch training no index. We're using PyTorch because it's not really optimized for anything. It's something kind of straight off the shelf that you would be able to pull down on your own. And we can look at these task definitions, and you'll see here that the only thing that's different is the repository that we're pulling it out of. So you can see that we've got the PyTorch training and then the PyTorch training no index. Importantly, there are no keys in here. There's no metadata. There's nothing that we have to do to this task definition to use Seekable OCI or to not use Seekable OCI, right? We're going to enable all of that in the background under the covers. There's only one piece of information that we need to have in order for Fargate to recognize that this is a Seekable OCI image and then be able to implement it. And you can see that here when we look at the repository. You can see the image down at the bottom, and then you can see the SOCI index file. And that SOCI index file, and we can go way deep into the woods on how these get generated and how they get put together, but we're going to save that for a workshop that I'm going to talk to you about here in a minute. But it's what tells the Fargate where all those files are and how to load them. So you can look down at the bottom, you can see that the image itself is 1.2 gigs, so it's a fairly sizable image. And what we're going to do here is we're going to set up a little test. We're going to go in and we're going to deploy multiples of each of these images. And we'll do that. We could do that from the command line. We could do that from the console itself. But what we're going to do is we're going to try to see what we can do about minimizing that 1.2 gigs worth of file size that we need to be able to pull down. So we're going to use the ECS run task API here. And you can see we're going to create two of each task instance. We're going to create 2 with the PyTorch training image and then 2 with the PyTorch training no index image. We run both of those, and we'll see them start up. And then when we look over, we're going to see all 4 of those task definitions. And we can sort these by the task definition name, and we can see that we've got 2 of each. We've got 2 that should be SOCI optimized, and we've got 2 that are just the standard image that's being pulled from ECR. So same image repository, just different images themselves. And we can see that the 2 that we used for the PyTorch training, the 2 that were indexed, started running almost immediately. The 2 that are not indexed, that we look at down at the bottom, we can see that they're still pending. And so this is where we talk about that SOCI index, where we've laid out for Fargate where all of the files inside that image are. And when Fargate calls a file, rather than having to download the entire image and then be able to find the file, it can simply go get the image that it needs specifically, pull all of those down, and then use that to start. So we see we've still got the last status of the 2 that were indexed as running. We've got the last status of the 2 that were non-indexed as pending. And if we wait long enough, right, and this is that part where we're trying to, maybe make the speed of light just a little bit faster because that would be helpful for developers, what we'll see is that everything will eventually come up. Now, the value of this to you is that delta, right? The value to you is the way that I've always done it takes this long, and the way that you're giving me now, that there's no cost overhead, all we have to do is index these images, is less. What is that delta? Now, it's going to be very dependent on the image, right? We chose a pretty, this is non-optimized. We definitely could have done something that looked way different, that was like a huge delta in there. I wanted to use something that was probably familiar to everybody in the room. So we'll flip back over here, and there's a Python script, because, generally the entire world runs on Python scripts, so we might as well use one here too. There's a Python script that we're going to use and call that ECS API, and what we're going to pull back are the download time and when it started. So we can see the created at versus the started at columns. And then we can calculate how long it is that took. And you can see here that the non-indexed PyTorch training image took 78 seconds on average across those 2 instances that we used to pull that down before that task was able to move into running and before that task became responsive to customers. For the PyTorch training, where it was indexed, we cut that down by 74%. It didn't cost you anything. All we had to do was index that up front. We had to copy that index into the repo with the image, and then nothing else. We built the exact same task definitions we've always built. We put them in the exact same ECS clusters that we've always put them in. We got a 74% reduction in the amount of time that it took to start that task. This is when Nick talks about these are the problems we like solving for customers. This is where we understand that it's great to have all of these additional features. If I have to break my entire workflow in order to be able to take advantage of them, we haven't done anybody any good. So hopefully this is a good example, not just of SOCI, but kind of that type of innovation that we want to build in there. For those of you who want to know more, and Nick had this on his slide, but I wanted to put it up here bigger in case anybody wanted to take a picture, we have a full hands-on workshop for Seekable OCI, where you get to go in and play with it and build an image and deploy it and see what the time would be and build it into an ECS task definition and then actually run it on an ECS cluster. And so we'll do that tomorrow. Hearing about what we're doing, hearing from the people who own the product, why we're doing it and where we're going is great. Seeing demos of things that are actual real that you can go out and work on, particularly when they don't cost you anything and they make time move just a little bit faster, also great. But by far, the best way that we have to be able to help you understand kind of what's possible is bringing customers up to be able to talk about it. So with that, I want to turn it over to Grant Milstead, and he's going to talk a little bit about how he's been using all of these serverless technologies to make United Airlines move a little faster. All yours.
Thanks, Jeremiah. My name is Grant Milstead. I lead up customer technology at United. And to start with the United story on ECS, it actually starts with the United story. United is about connecting people and uniting the world. And we do that at a pretty massive scale. About 500,000 customers to 460 destinations every single day fly on United. And there's two things I absolutely love about doing digital and customer experience at United. One is the moments that those customers are going to is what matters most. It's weddings, it's funerals, it's AWS reInvent. It's things that matter to those customers. The second is the scale. The scale of those numbers is incredible. It's almost like a top 50 kind of retailer and a top 50 logistics company had a baby, and that created, the size and complexity of United. And so you can think of us as kind of a software company within an airline. And so when Nick asked me to tell a story about ECS, I figured I'd leave the technical details to some of the team, but I'd talk a little bit about kind of what we're doing with it to enable customers. And it starts in maybe a little bit of an unlikely place. The picture on the left-hand side, this is a picture of the daily departures and arrivals in the New York metro area. If you're from New York, you may understand that if you drew a 12-mile radius around Manhattan, you'd cover 3 of the largest airports in the United States: JFK, LaGuardia, and most importantly, Newark Liberty's Airport. There's 3,500 departures out of New York every single day. And as you can imagine by looking at that depiction, even on a blue sky day, things can be a little complex, and there's a lot of people going to and from New York. But if you add in any kind of element of variability, albeit weather, things can get even more complex. I chose that picture on the right-hand side, not because it's raining in New York, but it's raining around New York, which can change the airspace. Believe it or not, there's only 3 places on a map that you can depart Newark's airport, and if one of those are cut off, 33% of your departures might be impacted. So weather's a little bit complex. So if you take New York and weather and put them together, what do you get? You get pretty incredible digital volumes. Some of our digital properties, when weather strikes, surge 2 to 8x. I thought it was pretty ironic. I'm presenting today on Cyber Monday. Last Friday was Black Friday. These are planned events. Companies plan their whole year for last Friday and today. And if you run an airline, you actually learn that we have Black Friday and Cyber Monday as an unplanned event. And we do it 40 to 60 times per year. It's pretty tough to get ready for that kind of scale that goes up really, really fast and really, really high. And then it comes down on a blue sky day. But the other aspect is, this is exactly what I want. I want our customers to self-service. This isn't a problem. I want our customers to use the app instead of standing in a customer service line at the airport. Never do that, by the way. The app has real-time information. Go to the app. So we started thinking to ourselves, so we've got some complexity. There's unplanned events like weather, and it drives incredible volume. What should we do with that to help our customers? And I haven't quite figured out how to control the weather, but if I do, I'll try to solve that. But what I can control is the experience that our customers have when weather strikes and the unpredicted aspect of that strikes. And what our customers told us is they want control. They're in an uncontrollable situation, and so they want control, and they want to feel like they can manage their travel in the instance. And that's where AWS comes in, and that's where ECS comes in. And that's why ECS is powering the United mobile app, the most downloaded app in all of air travel. And so one of the great examples of what we've built with that is something internally we call Trip Assist. And it's just what I said. It's giving customers the control of how they can manage travel when unfortunate situations like delays and cancels strike. And what do you need in those moments? United automatically rebooks you on the next available flight. We give you all the information about your flight status so you can feel informed. We give you information about your bags to let you know if you checked them, what's going to happen to them and where are they going. And then in the unfortunate situation, maybe you need a meal at the airport or maybe even a hotel stay. We give you electronic vouchers, electronic credit cards in the airport, electronic reservations to help you along the way, giving you control in that situation. And delays and cancels is now a feature. It's a mode in the app. We went from vision of a storm hitting New York to implementation in just 2 to 3 months. And how we did that and why we did that is really because of the foundation we have on ECS and the foundation of serverless. It allows us to focus on our customers and what they need, and it gives our developers time to really focus on that aspect in code rather than focusing on managing infrastructure. Now, I said I was really going to talk about our customers and business, but I guess there is a little bit of technical in here. The United mobile app, runs on a couple hundred services. Throughout the day, we span about 2,000 ECS tasks. But I think the thing that's more important or more exciting to me about the architecture is where we started from and where we've gotten to. One of our imperatives is speed to market. I want to build things for our customers, and I want to get it out fast. And one of the ways that I measure that is the United app is released to the App Store about 30 times throughout the year. It's faster than once every 2 weeks. My nearest competitor is doing 10 or 15 releases less per year, less capability to their customers than we're delivering to United. And how we got there is we actually started from a place of on-prem, monolithic services and applications. We used to do what I call kind of one fine day deployments, which is every couple weeks, hundreds of services would deploy on the same night because they had to. And believe it or not, we were pretty good at it, but it required a lot of manual effort. And so in our focus of getting speed to market and what you're seeing in the delays and cancels capability I talked to was really refactoring those big monolithic services down into small services that could run in containers and run as tasks. And that really enables us to have two things. One is we can independently deploy those services and make changes much, much more rapidly. And two is we bake a lot of the capability that we used to manage ourselves directly into the task. We run Amazon CDK. And in that, we have patterns that go straight into ECS around security, around observability, and around our resilience patterns for disaster recovery and how we manage our loads. And so all of that is baked in, which enables our teams, again, I'm going to say this again, to focus on our customers and delivering great innovation and more releases than our competitors with that. And then lastly, if you kind of look at United as a whole across ECS, I think Nick said he has 2 billion tasks running in a day. We're not quite that many. But we have a huge footprint now across United where application teams have found the benefits of serverless, not just in the mobile app, but across 7,500 services in United, both employee-facing technology and customer-facing technology. And what I found most interesting in this is we started investing in serverless. You see that line in 2020. It was pretty humble beginnings. And if you recall what was happening in 2020, it was a pretty challenging time to be an airline. It was also a pretty challenging time to talk about investment when we didn't have a lot of customers traveling. There were days where we had more employees at the airport than we did customers on our airplanes. But we made a decision that to really refactor the applications and the technology, we knew that travel would come back and we wanted to get ready for it. And so we made a decision in 2020 to say, hey, let's start investing in those workloads. Let's containerize our apps. Let's start moving things to ECS and getting the benefits of serverless in our applications and driving that refactoring to really make our applications nimble and fast. And you see we've ramped up in a pretty incredible way. I couldn't figure out exactly the best way to measure it. And so that's actually a chart of virtual CPU hours per week. And we're up to 25 million now in year 3 of our journey on ECS and still counting. So it's been an incredible journey. So when I say United it runs on AWS and is powered by AWS, I guess I should really say United runs on ECS. And we're incredibly excited about what we've been able to do for our customers on this platform. And we're really, really excited about where we go from here. So with that, I'll invite Nick back up.
Okay, so now we get to sit on these uncomfortably high chairs, and we're going to have a little bit of a discussion, a Q&A. I love that story. Really good example of the kind of things that you can do to move fast and meet the needs of your customers. So I wanted to ask you, when you started on your journey, you said you were monolithic, on-prem, and you went through this journey to where you are today. But going back to the beginning, how did you choose serverless amongst all the options that you had available? What were the trade-offs that you considered there?
Yeah, it's a great question. I got to be honest, we didn't choose serverless to start. It was a moment in time where really kind of our path was first focusing on, we already had a 100-year-old airline, so we weren't starting from scratch. And so our first focus was really around refactoring to be able to run in containers and taking that monolithic application and starting to break it down. And we started there, and I think since we had a lot of experience running things on-prem, the most natural thing to do is to kind of continue doing some of the things that you were doing in the cloud. And so we had container-based applications. You can run those containers in a few different places, and we tried all sorts of different ways to run containers. And the things we somewhat assumed we needed, control of that server, be able to turn all the knobs and the dials to be able to kind of make those services and that compute run exactly the way we wanted it to, over time we found we actually just weren't using it, and we didn't even need that capability. And so that's really kind of what started for us, the migration over to serverless. And I think the things we left behind, we didn't end up missing all that much. And it kind of went back to some of the storytelling that I was doing earlier around it really enabled our application teams, our developers, to focus on code and focus on building great features. And the feedback was fantastic, and so we haven't really looked back.
Yeah, that's the same story that I've heard from lots of customers, and I mentioned that a little bit in talking about security. Where there's been just a 180-degree flip where initially you think you need these things and you don't want to give them up, and then eventually you get to the point where you say, not only do we not need them, we really don't want them, and please take these off our hands. So once you made the decision to go serverless, and now you've gotten to a really good place and scaled to really mind-boggling scale, there must have been some interesting challenges along the way. And I don't just mean necessarily technology, but to go from on-prem monolith to serverless in the cloud, like your teams, your processes, even the skill sets that you have must have gone through some evolution.
Yeah, I mean, on a PowerPoint page, it looks pretty beautiful and painless, and there were no mistakes along the way and no challenges. But I do have to say, it was definitely a journey for us. And part of that journey is actually really good because the biggest asset we have at United is our people. And one aspect of all of this is getting them up to speed in terms of the skills that they need to run in the cloud, the skills that they need to run on services like ECS and Fargate. And so I would say one of the challenges is when you're a large company like United, you've got to figure out where to start. And it's not like we can take some of our production workloads out of service for the day to allow people to tinker with them and play with them. You have to find a place that you can start where it's okay to fail. And so part of our process was, as we would containerize workloads, we'd start to look at what's the smallest aspect of that workload that we could break off. How do we put that in an A/B test or a canary test that would allow us to put something out there, and if it didn't work, pull it back without allowing customer impact? And so those type of scenarios were really the first aspect. And then the second aspect is, we're a 100,000 person company. We have a couple thousand technology professionals. And so as people are learning across the organization, one of the challenges we ran into is how do we propagate that learning and how do we share those patterns? And that's where some of the capabilities like AWS CDK came in, where we've extended the CDK. We have that checked into a repo at United, and DevOps team and developers can contribute directly to that, and they can use the ECS patterns that we've deployed, and they can also extend it themselves and add more capability over time. And so being able to propagate that knowledge to our teams and being able to create a little bit of repeatability is a challenge, but it's something that we've kind of learned along the way, and we've enabled a lot of other folks to learn through that as well.
You know, you hit on one that I'm really passionate about to a point, which is around experimentation and the ability to fail. You look at something like that Sochi innovation that we just talked about. Going from 80 seconds to 20 seconds might not seem like that big of a deal. But if you're a team that's evaluating going to Fargate, you're trying to figure out, should we run on this thing? Let's run some experiments. That actually makes a big difference, right? If you can go from 80 seconds to 20 seconds, you can do that many more test runs in a day, right? And you can get to that answer quicker. And so, like, you know, that ability to experiment and fail and try things is actually one of the big, I would say, sort of organizational benefits to serverless technologies. So, you know, you're at a really interesting place right now. You're delivering these really innovative capabilities at a faster pace than others in your industry. What's next for United with AWS and serverless?
Yeah, we're definitely not done. You know, I think the thing that I'm most excited about in terms of what's next is actually what is next for United. We have an initiative, believe it or not, it's called United Next. And it starts with, we've got over 800 aircraft on order. And to put it in context, that's almost doubling United's fleet from what we have today. And so we're going to be the world's best and world's biggest airline over the next 5 to 10 years. And for the digital guy in the room, you know, that means that kind of new opportunities and new challenges for our team. Our airports are going to have more passengers. We're going to have more aircraft per day to operate and handle the logistics on. And it's going to create a lot of great opportunities for self-service in our digital channels, innovation for customers in that kind of ecosystem that can get congested in airports and air traffic control. And so I'm just really excited about digital being at the forefront of the growth at United. And we've had so much learning and gotten ahead of that in so many ways in everything that we've done in AWS thus far that I'm just really excited to see the innovation that's going to support that growth for United over the next few years.
Awesome. Well, thanks. I think that's all of our questions then. And thanks, everyone, for coming. It's really fun getting up here and telling you about all the things that are going on and talking about the philosophy and the way of life of serverless, and love hearing from United. So thanks, everyone, and have a great day. And we have a feedback slide that we can share with you as well, where you can provide feedback for us. And there are some related sessions that I encourage you to attend. There's one tomorrow and one on Wednesday from some of our senior leaders at AWS talking about innovations in compute and serverless. Tons of other workshops and chalk talks and things happening as well this week. Encourage you to check out the catalog. And so with that, thank you very much, and I hope you have a great reInvent. Thank you.